and welcome back to Josh Does Math. In this video, we're going to be doing a problem that involves the tangent line to a curve, and it's going to involve the derivative of the curve. So, let's read the problem. Consider the part of the curve y equals 1 over x that lies in the first quadrant. Okay, so here's what we're looking at. The graph of 1 over x looks kind of like that. And it's also down here, except for they're just talking about the first quadrant right here. So we don't care about this at all. I'm actually going to redraw this just so it's a little bigger since we're only looking at the first quadrant. So we're looking at something like that. Okay. And draw the tangent at an arbitrary point, x naught, y naught, on this curve. Okay, so we're just picking a random point on the curve. Okay. Find the area of the triangle formed by the axes and the tangent. Okay, so let's just say I pick a point right here. Now if I make a tangent at that point, it's going to cross the axes. And where it crosses the axes, we're making a triangle. And whenever you fill in that triangle, we got to figure out what that area is. Okay. So the first step is probably to figure out the equation of this line right here. Don't know if that's the first step you should be doing, but it seems like that's a good starting point. So let's do it. Our curve is f of x is equal to 1 over x. And in order to find the equation of this line, we're going to need the slope of this line. Okay, so let's do this. We're going to use the definition of a derivative. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Now we can just start filling this in with our function that we're given. The limit as h goes to 0 on f of x plus h minus 1 over x all over h. And I'm going to do a step right here where I find common denominators. So I'm going to find the common denominator between this term and this term. And that common denominator is x times x plus h. So we'll use that to get these in terms of that same common denominator. And that's because if I were to just plug in h is equal to 0, right here and right here, I'm going to get 0 over 0, which is an indeterminate form. So we'll use these common denominators and see if I can simplify it a little bit. So this is going to become x minus x plus h all over x times x plus h all over h. And we can just move the h into the same single denominator there. And you're still going to get 0 over 0 if you plug in h is equal to 0. But we can do a little step right here. This is equal to the limit as h goes to 0. I'm just going to distribute this negative right here. So this becomes x minus h all over h x plus h. And this x minus x cancels with each other. We're left with this. And as you can see, there's a factor of h in both the numerator and denominator. So we can cancel those two h's, and we're left with negative 1 over this as our denominator. And now why don't we try to plug in 0 for h? Well, you can see that we get negative 1 over x squared. So this means that f prime of x is defined by this equation. Okay, so you give me an x value, I plug it in, and I can tell you the rate of change at that x value. Well, we picked some point right here. We'll call it x naught, comma, y naught. y naught. But we have x naught, y naught. So if I plug in x naught to here, I can get the rate of change at that given point x naught. So f prime of x naught is equal to -1 over x naught squared. All I did was plug in x naught. However, for our equation of our line right here, you can see that at this point, the derivative is going to be m, the slope of our line. And we can write our line as y equals mx plus b. So I'll write that out right here. Y equals mx plus b. And at our given point, we know what y naught is. We know x naught. We know m. We don't know b. So I'm going to solve for b in terms of x naught and y naught and things that were given. So for our point, I'll plug in y naught is equal to m for that point, which is going to be -1 over x naught, as given right here, times the x at that point, which is x naught, plus b. So this should be negative x naught squared in the denominator. And if you just simplify this, you get -1 over x naught and you can see that b is equal to y naught plus 1 over x naught. That's what b is equal to. So we can now modify our equation. Instead of having just some generic b, we can actually put this in for b. So we get y equals, I'm also going to put in this for m. So that's -1 over x naught squared times x plus y naught plus 1 over x naught. In other words, at some point of tangency, x naught, y naught, this is our equation of our line. Okay, so what are we looking for now? We're supposed to find the area of the triangle formed by the axes and the tangent. So if we're looking for the area of a triangle, you're going to have the base and the height. I'll call the base capital B, and I'll call the height capital H. I'm calling them capital B and capital H just to differentiate them from our y-intercept and our h that we had in the limit up here. So we're looking for capital B and capital H. Well, let's look for capital B first. We know that capital B is going to be whatever the x value is at this point that's right here. In other words, the x value whenever y is 0 on our line of tangency. So we just take this equation and we're looking for b. So we're going to plug in 0 for y, and that's going to give us b. So I could solve this for b and I would get a value. I'll do that really quickly. So this is going to end up being -y naught minus 1 over x naught is equal to -1 over, this should be squared once again, x naught squared times b. And I'm just going to multiply by negative x naught on each side. So I get y naught x naught squared plus x naught is equal to b. So there, I have a value for b now in terms of x naught and y naught. Well, how are we going to figure out h? Well, same way. H up here is going to be the y value whenever x is 0 on our straight line. So I just take this equation, h, our y value, is going to be equal to -1 over x naught squared times 0 for our x value, plus y naught plus 1 over x naught. If I solve this for h, this whole term just goes to 0. So I'm left with h is equal to y naught plus 1 over x naught. There we go. And now we know that the area of a triangle is equal to the base of the triangle times the height of the triangle divided by 2, half the base times the height. And I know the base in terms of x naught and y naught, my point, and I know h in terms of x naught and y naught. So I'm just going to plug those into this equation. So I'll plug in b, y naught, x naught squared, plus x naught. And I'll plug in h, that's y naught plus 1 over x naught. This is all over 2. And now I'm just going to do a quick FOIL up here to simplify this a little bit. So this becomes y naught squared, x naught squared when I do these two terms. Now if I FOIL these ones, I'll get y naught, x naught. If I FOIL these ones, I get another y naught, x naught. And if I do the last ones, I just get 1. This is all over 2. So that's the area formed in terms of x naught and y naught. But this can simplify even more. I know that for any x naught point, my y naught point will be found by using the equation of the line up here. Okay, so that means that every y naught is equal to 1 over x naught. So I'm just going to replace every y naught with 1 over x naught in this equation. So I get x naught squared over x naught plus x naught over x naught plus x naught over x naught plus 1. This should be squared right here. This is all over 2. Okay. Each of these terms you can see cancels and just becomes 1. So this is 1 plus 1 plus 1 plus 1 all over 2. In other words, this is 4 over 2, which is just 2. So therefore, from this problem, you can see that if you pick any point within this first quadrant right here, and you're looking at the function y equals 1 over x, that if you draw a line, a tangent line, and you figure out the area that's trapped between that line and your two axes, you're always going to get 2 no matter if you pick a point that's right here like where I drew, or a point that's way up here on the line, or one that's way down here, you're always going to get 2. So that's this problem, and thanks for watching.